Code is Darren Nattinger, and he is presenting on ludicrous ways to fix broken LabVIEW code.
That's it? That's all the intro I get?
That's all the intro you get, man.
All right, well, we'll see what I can do with that.
Probably nothing.
Thanks for nothing, Jeff.
You're welcome, anytime.
I'm Darren Nattinger. I work at NI. I've worked there for 23 years. Most of that time was in LabVIEW R&D. I'm in tech support engineering now. And today, I'm going to talk about a lot of the things that I've learned and worked on the past couple of years since being in the tech support organization. Some of the ludicrous, ridiculous ways that I've helped people fix their LabVIEW code. Now, if you've ever seen one of my presentations before, you know that my first slide after the intro is a place where you can download everything that you're about to see. Particularly people in the back of the room, if you have a little trouble seeing the stuff on my slides, you can download the slides right now. You can follow along on your laptop. It might be a little easier to see. I'll try to zoom in where appropriate, but you can grab the slides right now if you want. Have it right there on the screen in front of you. Also, I've given a lot of presentations. All the slides, all the demos, all the recordings, everything's on ni.com. bit.ly/lvdnat down there in the bottom corner. You can download every presentation I've given in the past decade, except this one because it's not there yet. But yeah, if you want to grab the stuff for this presentation, you can grab that right now at bit.ly/ludicrous LabVIEW. All right, not to be confused with brainless LabVIEW, which is another presentation I've given before. All right, so my outline is first, remember how Nancy had a bunch of disclaimers in her presentation yesterday? Well, I got disclaimers too. And after that, I'm going to get into a brief autobiography about myself and my relationship with LabVIEW. And then we'll get into the main part of the presentation, which is a ludicrous play that was originally going to be in 10 acts, but that ended up being way too long. So then it was going to be in 5 acts. Then I realized that there's someone at NI who I would offend deeply with that one act. So I decided I didn't want that to be in print. Y'all can ask me about it at dinner tonight. So instead, we're moving down to 4 acts and a prologue. That is what we have today. So first, let's talk about disclaimers. So I rejoined, since when I first started at NI, I did tech support, but rejoined the tech support organization a little over 2 years ago. And in those 2 years, I have seen a lot of broken LabVIEW code. Now, when I use the term broken LabVIEW code, I'm referring to crashes and hangs and build failures and all that kind of stuff you might experience when trying to work on a large LabVIEW application. Now, in my role in the tech support organization, my #1 goal is to get you guys unstuck. No matter what, that's the first thing I'm trying to do. Secondary goal, let's get some bugs filed to LabVIEW R&D, get them prioritized, get them fixed. But my #1 goal is to get you guys unstuck. And some of the ways that I have gotten you guys unstuck are just plain ludicrous, all right? But there is a good chance that some of y'all will encounter some of the situations I describe in this presentation. Maybe not exactly the same situations, but similar situations. And I'm hoping in the back of your head, you will remember some of the ridiculous things you've seen in these slides, and maybe that'll help you get unstuck. Now, I would prefer you not get stuck in the first place. So that's the prologue of my presentation. That's what we're about to start up. I'm going to try and tell you guys things you can do to avoid getting stuck in the first place. Also, as usual, this presentation does not necessarily reflect the opinions of my employer. That's going to be clear because I'm going to be telling you guys to not use features in LabVIEW. So and I would probably not say that on paper. All right, so I have a couple of wishes for this presentation. My first wish is that NI will see this presentation and see these ludicrous things. You guys may remember last year, those of y'all that were at GDevConNA, Eric Reffick gave a presentation and he did one of those things where he took surveys and he was like, what features would you guys like to see in the next coming releases of LabVIEW? And there were choices on that list like better integration with Git and better CI workflows and stuff like that. And I've seen him give that survey many times, and there's never an entry on his list of things for you to vote for that is editor and runtime performance and stability improvements. If that were on his list, I would pick it #1 every time, but it's never on his list, so I always have to write it in as an other. Well, my wish is that NI would prioritize these sort of things more highly, and so that's what I'm hoping. After this recording gets out, the people at NI see this, they get mad at me because I'm an NI employee and I'm saying all these things. I'm hoping that at least one outcome is that we'll see a higher prioritization of those issues. My wish for you guys, LabVIEW programmers like myself, is that when you encounter these ludicrous situations, I know it's so easy that once you find that workaround, you just move on your merry way. I know a lot of you guys are, charging billable hours. Like, you don't have the time or the inclination to stop, turn off the timer, go put the stuff together in a zip file that you can then send off to NI. Please do that. I'd love for us to get more bug reports and more things that we can actually have concrete issues or concrete reproducing situations in LabVIEW R&D that we can fix these issues. All right. So let me give you guys a brief autobiography of myself and LabVIEW. That's my icon on the NI forums, the little cheeseburger there. I picked that back in 2001 or 2000, whenever NI first started NI forums. There was a list of 20 glyphs you could put. I know Jim Crean picked the little surfboard guy. I picked the cheeseburger, and that's been me ever since. All right, so in December 1998, I graduated from the University of Texas at Austin with a BS in mechanical engineering and zero programming experience, really. There was one lab I took where there was a LabVIEW program that was written in LabVIEW 3.0, but it was already made. We just clicked the run arrow to do some measurements of something. So I didn't do any programming. All of my classmates were getting jobs at oil companies in Houston and automotive companies in Detroit. And I was recently married, and I didn't want to leave Austin. So I was looking for a job in Austin, and I found a job at NI as an AE. We called them AEs back then. We call them TSEs now, where I did LabVIEW and DAC support. My first version of LabVIEW was version 5.01. So I have never known a LabVIEW without undo. So it's apparently I'm a lucky bastard is what I've been told. So so I got LabVIEW Basics 1 and 2 training, started with LabVIEW 5.01, did that for most of 2 years, almost 3 years. And then I got a job in LabVIEW R&D as a LabVIEW programmer, where I was for a very, very, very long time. If somebody was born the day I started in LabVIEW R&D, they would be able to vote the day I left LabVIEW R&D. I was there for over 18 years. And then in June of 2020, right in the middle of COVID, I moved over to the TSE group. And my job in TSE is to be a mentor to the junior LabVIEW engineers, to work on training and exercises to help them get better and more comfortable with LabVIEW. But a big part of my job, and what I'm going to be talking about today, is helping with LabVIEW escalations. So when there's a support issue with LabVIEW, the junior engineers really can't get moving on it. They kind of get stuck. They bring me in, and I help out with those issues. So I did 2 years of supporting features. I did 18 years of developing features. And now I'm in the middle of 2 years of supporting features again. So that's me and LabVIEW. So speaking of NI support, since that's the department I work in now, let's talk about some LabVIEW features that if you use them, you better have us on speed dial because you are probably going to run into issues. But before I talk about those, let me talk about essential features in LabVIEW. So this slide is going to contain features of LabVIEW that, in my opinion, are essential to large LabVIEW application development. The first one is pretty obvious. App Builder, we're deploying our applications. Can't really, I mean, there's a few people I've heard of that everything they do is in the LabVIEW IDE, including their deployed code. Kind of weird, but it happens. But for the most part, we need App Builder. We need the project window because we can't build EXEs, DLLs, et cetera, without it. In my opinion, we also need project libraries. They are essential for code organization, for code namespacing. I know at least one CLA who refuses to use libraries, and all of his VIs have prefixes on their names. But in my opinion, they are essential. I think LabVIEW classes are essential. Again, similar to libraries, but we also get private data, dynamic dispatch. But a large LabVIEW application can't live without that. And then, of course, type definitions. These are all features that I am not going to recommend that you not use. Sorry for the double negative there. These features are very frequently involved in broken LabVIEW code. App Builder is going to return errors. Sometimes, to me, it seems more often than not. But you have to use it in order to deploy your large LabVIEW application. I'm not going to recommend avoiding these features. We need these features. These are essential. But unfortunately, these features are often used alongside what I consider non-essential LabVIEW features. Get your tomatoes handy. You're about to start throwing them at me. So the first non-essential feature that I think we should avoid in LabVIEW is based on what I have seen in the TSE group helping out with support issues is, drum roll while I get my screen back, XNodes. I think XNodes are a non-essential feature in LabVIEW and we should avoid using them. My next one, I'm sorry, malleable VIs. And then my next one, a lot of y'all already know what it is PPLs. So in my opinion, you should avoid these features when possible, particularly when you use them with each other and when you use them with LabVIEW classes and type definitions. Again, let me reiterate, this presentation is my opinion. There are people who have been successful with these features, like, I don't know, someone who's going to present later this afternoon on PPLs. But in my opinion, these features should be avoided when possible so that you don't even have to get stuck in the first place. So first I'm going to talk about XNodes. Please be participatory in this part of the presentation. Who does not know what an XNode is? Thank you for being honest. I'm going to show you guys what an XNode is. Prepare to have your mind blown. All right, so if you're in LabVIEW, and I'll try to zoom in where appropriate, but you've got sub-VIs, right? Like, let's say, recursive file list. So that's a sub-VI, so you can go look on its block diagram, right? And on its block diagram, maybe there's another sub-VI, and you can open it. But at some point in LabVIEW, as you're digging down, you're going to get to the point where you can't dig down any further, right? This block diagram only has, oh, this looks good. Yeah, this is zoomed in real well. You're going to have a point in your block diagram where you can't dig down any farther. Those yellow things are referred to in the LabVIEW help as functions. Those of us that have been programming in LabVIEW for a while, we tend to call them primitives. But those are pieces of the language that are backed by C code. And LabVIEW programmers can't dig any further than that, right? Hopefully that was pretty obvious to everybody. Well, there are some things in LabVIEW that look like they are built-in functions, but they're not. For example, match regular expression. So that thing, that sure looks like a normal LabVIEW function, right? Like, you know, you can grow it. It's got context help, kind of like a property node. You can grow that, and it's got context help. But a property node, you can't dig any deeper. And an X node, you can dig deeper. I'm going to right-click on this, and I have a right-click menu option on my computer that says XNode Wizard Menu. What the heck is that? So that menu item is added by a private INI token that I have in my LabVIEW that most of you probably do not have. But that lets me see that this thing on the diagram that looks like a primitive is really a thing called an XNode. I'll prove it to you. So if I click on generated code, here, let me shrink it down actually so the diagram looks better. If I click on generated code, so this diagram is actually, where's Control U? So this is the code that is sitting underneath that match regular expression node on the block diagram. This is G code. So a LabVIEW programmer like yourselves could write an X node where you define G code that generates that diagram, that provides the growable functionality, that draws what you see on the function. That's pretty exciting, right? Don't ever do it, okay? Pretend you didn't see any of what you just saw. So people ask me, well, how do I know what's an X node and what's not an X node? Like that's a pretty obvious question, right? That thing, if you had never heard of X nodes before, which several of y'all hadn't, that thing just looked like a built-in function. How do I know which things are X nodes? Well, there's not an easy answer to that question, but I'll point you in the right direction. So I'm going to search my VILib for any file that ends in .xnode. And you're going to see, oh crap, there's a bunch of stuff in there. So people in the back room might not be able to see the list very well. Let me zoom in a little bit here. So database variant to data, the function on the database palette, that's an X node. The error ring is an X node. There's several X nodes having to do with like the express VIs that deal with dynamic data type. If you've ever used function blocks, the storage VIs, the ears on the side of a timed loop, those are X nodes. Match regular expression we see in the list, and those are the most interesting ones. But anyway, yeah, several parts of LabVIEW are actually XNodes, right? So,
Darren, can I ask a question?
Absolutely.
When you recommend that we avoid XNodes, are you saying avoiding creating our own, or are you saying avoid the ones built into LabVIEW?
I'm saying both.
Okay.
So
just wanted to clarify.
Avoid the ones that ship with LabVIEW. I never use match regular expression. Match pattern for life, baby. I figure out a way to use match pattern, so I never have to use match regular expression. Now, unfortunately, if you're programming LabVIEW FPGA, for example, every single thing on an FPGA diagram is an XNode. There's no way to avoid them. I'm sorry. But in desktop programming, there's generally an alternative to using XNodes. There is a community of people on Lava who write their own XNodes and share them with each other. Don't write your own XNode. You're just going to have problems. Don't listen to those people when they talk about how cool they are. And if you have XNodes and you're using PPLs, the problems can increase exponentially, as we will describe later on in the presentation. Next, I'm going to talk about malleable VIs. Who does not know what a malleable VI is? Everybody knows what a malleable VI is. Great. Okay. So there's really simple ones that ship with LabVIEW, like remove duplicates from 1D array. I love that guy. I use him a lot. Enum to array of enums. I use that one as well. Malleable VIs that are real simple, like operating on enums or operating generically on arrays, those are probably fine. But once y'all start writing malleable VIs and classes get involved, like a malleable VI with class inputs, good luck. If you start building those classes into PPLs, see you later. You're going to have tons of problems. So I suggest avoiding malleable VI. Hey, maybe some people in this room have done the things I just described and never run into a problem in their lives. You are living on borrowed time. I mean, not even if you're building into PPLs, but I get really frustrated when, so this happened to me relatively recently. A colleague was working on a large LabVIEW project, thousands of VIs, lots of classes, malleable VIs. He gave me his project. So I had never opened the project before. The VIs had never been compiled on my system because everything was source only. I open the project, everything compiles. Tons of VIs are broken in this code. So I go look on the block diagram and I see broken wires going into malleable VIs. I delete the broken wire, recreate the broken wire, and it's not broken anymore. That's ludicrous. I shouldn't have to deal with that. And the easiest way to not deal with that is to just avoid malleable VIs in the first place. People like to use them with their classes because it gives them clean APIs in their code. I would rather have a clunky API. I would rather have a poly VI with a bunch of instances on it than have to deal with the build issues I'm going to have when I try to build my project with malleable VIs in it. So please avoid those. Next, PPLs. Who does not know what a PPL is? A couple people. Okay, so I don't have a demo for this. I'm just going to tell you. If you have a LabVIEW library, a .lvlib file, it's got member VIs. It might have classes. It might have other libraries inside of it. And I'm speaking mainly to the two people that raised their hands. And you can, so those are all separate files on disk. Like the lvlib references VIs, references classes. There's a feature in LabVIEW where you can take that lvlib and create what's called a packed project library, which is a single file that contains that library and all of its dependencies. That's what a PPL is. It is also the #1 most common occurring issue in all of the support cases I have helped with since joining TSE 2 years ago. And I was talking with Brian Powell yesterday, and he said, you know what? PPLs are probably okay if you've just got a single lvlib and maybe it has one class inside of it, and you build that into a PPL, you're probably okay. But that never happens. You always have like all sorts of other stuff being pulled into your PPL. So in my opinion, just the problems that they cause are not worth the benefits that they have. Have you considered using LLBs? I'm totally serious. LLBs, they get crapped on all the time. I don't know why. They're pretty awesome. Don't store your source code in LLBs. That's dumb. Use a source distribution to take your source code and package it into an LLB. People like to use PPLs because they have a load time performance benefit. When loading a group of VIs into memory in LabVIEW, there is no faster way to do so than having those VIs inside of a PPL. But you know what the second fastest way is? LLBs. And LLBs don't have all the problems that PPLs have with build issues and all that kind of stuff. So consider using LLBs if you're just looking for like, how can I get my load time performance better? Oh, I'll use a PPL. Maybe you could try an LLB. But I know people are gonna insist on using PPLs. We're gonna see a presentation this afternoon about how great they are. So I have some guidelines if you choose to use PPLs despite all my warnings. Please make sure there are no XNodes in your calling code that's in your PPL. Try not to build malleable VIs into PPLs. I've seen several support cases come in because of build issues people have had with malleables being pulled into PPLs. It's really difficult, but if it's possible to not have classes in your PPL, that will probably reduce your chances of having problems. And at least try to follow this recommendation. Always build your PPLs to the same spot. And you know what spot that is? C:/PPLs. Now, maybe you want to put your company name there. That's fine. C:/my company PPLs. Also, this suggestion is only if like you're just doing Windows. Like if you've got a PPL that goes to RT and Windows, then you can't really follow this. But you know, if everything's going on the desktop, C:/PPLs. That way, install on a new machine, somebody else comes along, hey, where are the PPLs? They're always in C:/PPLs. Well, where do I build them? Always build them in C:/PPLs. That way, you just always know. And again, stick your company name on there. But yeah, always the same location. All right, now my colleague who y'all heard from yesterday, Derek Bomarito, wrote a couple of great articles on NI.com about how to solve some build issues that you can have, PPL-related build issues. So if you ignore all of my advice and you start using PPLs and you inevitably run into build problems, you can go read Derek's articles. All right, so that was the prologue. Now we're going to get into my case studies. Act 1, when LabVIEW features that you love break your heart. So we're going to start this off with a little-known LabVIEW quote from history by some schmo named Darren Nattinger back at NI Week 2018, who said, and I quote, "The error ring is fantastic. I love this feature." 2018, Darren. So many things I could tell you. All right, so we're going to come revisit this, but we're going to talk about an issue that came into support, which was that someone was, whenever they would do Control F to find things on their block diagram or their front panel in LabVIEW, LabVIEW would crash. This only started happening in 2021 SP1, so crap, it's a new bug, right? And it only happened when the active framework PPL, so someone had taken active framework LVlib, built it into a PPL and put it in their project. And that's when they had the Control F, whenever this PPL was in memory. So far, we've got two worrisome features. One of them is an essential feature, right? LabVIEW classes, I talked about before, those are essential. And one of them is PPLs, a non-essential feature. So on the Homeland Security Advisory System, I would say right now we are at an elevated risk of LabVIEW attacks. Okay, that's where we're at right now. We got two features that are going to make us worry a little bit. But the problem is, I couldn't reproduce the issue. I took active framework from my LabVIEW, built it into a PPL, tried Control F, it was working fine. Well, then I found out that the LabVIEW developer in question, he wasn't using the active framework library that's like it is in VILib. He was using a modified version of the active framework. And it's actually a documented way to modify your active framework. And that documentation is to tell you how to modify your active framework library so that all the parts of active framework are actually in the LVlib. Did you know that not all the parts of active framework are in the active framework LVlib? Here, I'll show you. So let's take a look at a VI like launch nested actor. And we will notice that we have active framework LVlib actor class launch nested actor. Okay. Let's take another VI from active framework like send message and wait for response from reply message class. Now, where did active framework.lvlib go? Turns out there are parts of active framework that are not in the active framework LVlib. I talked to Alan about this yesterday. He gave me a very simple answer about why it's not that way. He and I both agree that those probably should have been included in active framework LVlib, but they're not. So there's some parts of active framework that are not part of active framework LVlib. So some people who want to use active framework as a PPL will modify the active framework library, pull those things in, and then build a PPL, okay? So that's a little background on active framework. Now, I finally got a LabVIEW R&D, a PPL, with all the stuff included, so mimicking the customer setup. And LabVIEW R&D took a look at the active framework PPL, and they said, oh, there's a corruption in this PPL. I was like, oh, okay. And so we move on a little bit, and then I'm like, well, wait a minute, what was the corruption? And they told me, oh, one of the VIs in this active framework PPL is corrupted. And I said, well, that's weird. The source code, like, I'm just doing this from VI-lib. Nothing in VI-lib is corrupted. I was like, which VI is it? And they told me. They told me that the corrupted VI was reply message class do.vi. So I went and I looked at reply message class do.vi, and I was like, well, this is a really simple VI, y'all. It's got a queue function, it's got a sub-VI call, it's got an unbundle. What could possibly be corrupted about this VI? And then I thought, wait a minute, what's in that error case? Ah, crap! It's an error ring. Error ring is an XNode. You guys want to see the generated code of error ring? It's a really big string constant and a call to error cluster from error code. So that is the generated code inside of error ring. So that XNode was pulling in what was normal, but it turns out that there is a bug in LabVIEW where if there is an XNode in code that gets built into a PPL, it could corrupt the VI and cause problems. So I had a user who I needed to get unstuck. And I was in this situation where first we were using LabVIEW classes, then we were using PPLs, and now XNodes are in this situation. This is a severe risk of LabVIEW attacks. So severe that apparently you can't do Control F anymore in LabVIEW. So what did we do? Well, we went into the actual VI from Active Framework. We deleted the error ring. We replaced it with its generated code, which was just a call to error cluster from error code. It turns out that this customer, in his in the PPLs of his project, he was also using match regular expression in some of his own code. So even when he made this fix, the crashes were still possible. So he went in and got rid of match regular expression. And I wrote this VI analyzer test called find XNodes. So you can go download that from ni.com and find all the XNodes in your code and delete them because they're going to cause you problems. Now, granted, again, this was code that was being built into a PPL, right? We don't all build PPLs out of all of our stuff, but you could at some point build a PPL out of some code that happens to have an XNode, and all of a sudden you're going to have issues or crashes, right? So my LabVIEW developer that I was working with, he got rid of his error rings, he got rid of his match patterns, he rebuilt his PPLs. LabVIEW no longer crashes when he does Control F. In my opinion, being able to find things in LabVIEW is pretty essential to LabVIEW programming. In my opinion, he was stuck when he was getting these crashes. His team had to remember, oh wait guys, don't ever do Control F while we're doing development. Like, come on, that's ridiculous. So we got him unstuck with the ludicrous change of having to go through his code and find the XNodes and delete them, right? So we got a couple bugs filed to LabVIEW R&D. The first thing we did was we removed that XNode from Active Framework VI. So the next release of LabVIEW, that's going to be gone, so at least we don't have to worry about that. But then there's a second bug of more generally, why is LabVIEW crashing whenever we're doing a Control F? So we're gonna look into that, and that won't be fixed in like the LabVIEW that's about to come out, but hopefully they'll be able to fix it soon. So my recommendation going forward, don't use the error ring in your PPL source, or really don't use it ever, because why risk the issues when you could just use error cluster from error code.vi in the first place? So it broke my heart. I loved error ring. I told the world that I loved error ring, and then it broke my heart, so I don't use it anymore. So let's talk about another LabVIEW feature that I love. Class property nodes. There's some people that don't like class property nodes. I am not one of them. I think class property nodes are great. I use them all the time. Because a property node is a really easy thing to read on a LabVIEW block diagram. It is a really clear syntax. And you know what else? Come fight me, but I think text-based info on a graphical block diagram really improves readability. Don't really fight me. I don't think I could win. But I'm serious. You're never going to convince me that this picture on the right is better than that picture on the left. That's stupid. I'm sorry. You're never going to convince me Property nodes are super easy to read. Yes, it's text, but it's smaller, it's more compact. And I mean, look at all those I had to edit these icons and they still look ugly. So I like class property nodes. I love class property nodes. But one thing that I always tell people don't ever worry about is coercion dots, right? I don't care about coercion dots. Look, you got a U32 indexing out of an array. That coercion dot doesn't mean anything. You got a VI, like this is the DQMH and Q message VI. It's got a variant input, so you're going to get a coercion dot on anything you wire to it that's not variant. That's not a big deal. You got a class VI that has a static dispatch class terminal. Any child class that's wired into that is going to have a coercion dot. No big deal. But holy crap, watch out. If you ever see a coercion dot on a class property node terminal going into something that's type def. Holy crap, that is going to break everything. All right, I'm going to show you a quick demo here. All right, so I got a project here. I'll close these active framework VIs, and I got a project that has a class in it, and that class has a type def cluster as one of its data members that I'm accessing. Right? So, like if I were to do create indicator off this terminal, then we would see I get an indicator that is the type def of that guy, right? Now, there are a lot of changes that you can make in LabVIEW that will cause the situation I'm about to describe, but I'm going to show you one of the easiest ways I can reproduce it just for the sake of the demo. I'm going to go into this type def, and I'm going to change it to a strict type def. Then I'm going to save and I'm going to close, and now you see there is a coercion dot on that terminal, okay? Normally, coercion dots aren't a big deal, right? Well, here's the weird part. So I'm going to delete that wire. I'm going to do create indicator, and the created indicator has a coercion dot on it, okay? This is a bug in LabVIEW. This code is going to run just fine. This code might build into an exe, or you might get a build error, or when you run your exe with this in it, you might get searches for files that aren't in your project anymore. These are serious coercion dots whenever you see these. This is a bug in LabVIEW. It's a serious coercion dot. Let me show you the ludicrous way to fix it. By the way, it's not just the strict type def thing. This can happen if you like rename or move your type def. It can happen if you rename things in your class. I see this happen with a lot of projects, and it's really irritating. I just did the strict type def thing because it's an easy way to reproduce the issue. But if you ever see this happen, here's the fix. Go into the accessor VI that's causing you trouble. Right-click on the terminal and disconnect it. Then reconnect it. And now there's no more coercion dot. You might say, why don't you just close LabVIEW and reopen? Nope, coercion dot's still there. Why don't you force recompile? Nope, coercion dot's still there. This is the only way I found to get rid of it. There might be other ways. This is another bug, file to R&D, whatever. But if you ever see that coercion dot, you're going to have a build failure later. So make sure you address it right then. Now, remember with the error ring, once I started seeing those issues, I was like, okay, I'm never going to use error rings anymore. But I love class property nodes so much, I'm okay with this workaround. I'm going to keep using them, and I'm going to keep an eye out for those coercion dots. There are a number of bugs that have been filed to LabVIEW R&D on class property nodes over the years. Some fixed, some deferred. I still like the feature enough that I want to keep it. And remember, your takeaway from this is watch out for coercion dots, and text-based information on a graphical block diagram is perfectly fine, okay? All right, Act 2, App Builder Checkbox Roulette, which is the second worst kind of roulette you can possibly play. That's the first worst. All right, so has this ever happened to you? You've got code that runs and it works fine in the LabVIEW IDE. But then you go to build it into an EXE or PPL, and a broken VI shows up when you try to do the build. Or maybe the build happens, but then you try to run the EXE, and it's got a broken run error, or it's searching for missing files. If this has ever happened to you, you just might be the next contestant on Checkbox Roulette. All right, now, but before we play Checkbox Roulette, let's make sure we have to play it in the first place. I prefer to not play Checkbox Roulette. Let's mass compile our code. Let's make sure there's not any insane objects or corruptions or files missing that we don't understand. This one has bitten me before. You've got a conditional disable structure in your code, and you've got a runtime engine equals true case, and there's something broken inside of it. Well, you don't see that when you're running in the IDE. then you build the exe and all of a sudden it's broken. So watch out for that. There's a tool in LabVIEW. Maybe you haven't heard of it before. It's relatively recent. It's a VI called Find Broken VIs in Project. It's kind of like mass compile, but a little better in my opinion, because sometimes like you might mass compile the folder that your project's in. Well, maybe your project is referencing some stuff outside that folder because you've got crosslinks. This VI is going to find broken VIs in your project. Run this VI before you do a build. Especially if you've got a build that takes like 3 hours, because let's face it, we all have had those before. This VI only takes a couple minutes. So before you kick off the build, run the VI, make sure that there's not broken stuff. All right, and then of course, we all use source only because we all use source control, but that also means about once or twice a year, we're probably clearing out our compiled object cache to try to fix some bug in LabVIEW. So clear out the compiled object cache, mass compile again. Also, the control F bug I talked about before, notwithstanding, new versions of LabVIEW tend to have fixes for these issues I'm describing here with builds. So if possible, upgrade to the latest LabVIEW and install patches. That'll decrease the chances you're going to have a build issue. If all of that fails, let's play checkbox roulette. So in order, those are the 6 checkboxes in App Builder that have the best chance of fixing your build issue and getting you unstuck. I'm not saying you should have to enable debugging on your EXEs, but sometimes when you do enable debugging on your EXEs, it'll fix a build problem. And then down from there, disconnecting, I use inline sub-VIs. That one usually can fix, I think, malleable VI issues. Unused poly instances maybe can. It's hard to remember which one's which, because usually I just go in and start clicking. That's why it's checkbox roulette. You just kind of check some and see what happens, right? Also, there's the one about, here, I'll zoom in, although this is a low-res picture. But here, does my laser work? Hey, my laser works. This one right here, exclude dependent pack libraries. For the most part, you should be, your EXE that you're building should be linking to PPLs in their build destination location, which again, C:/PPLs. That way you reduce the chances that you're going to have linkage issues with your PPLs. All right. About App Builder checkbox roulette. So the epilogue to this is, if checkbox roulette doesn't fix your issue, you're pretty much going to have to contact NI support. If checkbox roulette does fix your issue, please contact NI support. Please give us some code that can reproduce the issue that checkbox roulette fixed so that we can fix App Builder, because we shouldn't have to be playing checkbox roulette. We need bugs filed against App Builder to make it better. I understand we all have workflows where once we get the workaround, we really need to move on. But if possible, it would be great for NI to get that code so we can make App Builder better. And if you avoid problematic features like PPLs, malleable VIs, and XNodes, there's a better chance that you won't have to play App Builder checkbox roulette in the first place. All right, so Act 3. LabVIEW is a parallel language, right? Right? So in LabVIEW Core 1, on your very first day, they show you a diagram that probably doesn't look like this, but it probably has some add functions or something, but it's like separate loops, and there's no data dependency between the loops. And you learn, we all learn, that one of the great things about LabVIEW is that the code is inherently parallel. Like if you write code like this, there's no data dependency. Once those first couple functions run, everything else can run in parallel, right? So maybe not, though. All right, so let me show you guys a demo. All right, so I got this VI here. And it's using Python node. And it's doing some math. And if we run it, there we go. Yeah, the first run had to load Python stuff. Okay, so it's just doing some sort of function in a Python. We're passing in a couple of clusters, doing some function. And we're running it, and we're getting pretty, I don't know. Actually, that's probably not that fast of an execution time, but you know, whatever, 0.06 seconds. Well, I've got this other VI that looks just like it, only I made a copy of that code, and I'm running them all in parallel. When I run this code, it takes 4 times longer. I'll bring the other one back up so you can see it. Yeah, so it runs a little over 4 times longer. So I guess the Python node, it doesn't work in parallel, right? Like I guess judging on this, there's some shared resource that the Python node has where you can't run them in parallel. But when this issue came to me, one of the TSEs that I was helping said, but there's a knowledge base entry that says it does work in parallel. I said, really? Point me to that. So he sends me a link to it. And I got the link right here. And so there's this article. Sure enough, executing parallel processes with the Python node in LabVIEW. A bunch of interesting stuff. And then there's this. Following is an example, calling two Python sessions. Note that the while loops are set to terminate after just one iteration. However, this instructs the compiler that these two processes should run in parallel. What? What? Also, can we all just kind of agree that your function 1 and your function A, come on, it should have been your function 2. So that's slightly less annoying than the fact that we actually, in this knowledge base entry, are saying you got to use these dummy loops. Well, when the junior TSE showed me this article, I said, that article's wrong. You never have to wrap code in dummy loops. That's ridiculous. Let's get this article edited. And while you do, please change that to your function 2. He's like, okay. But then I thought, wait a minute. I should probably try this. So I decided to try it. So I've got this VI, right, with these 4 Python nodes. So let's do a little LabVIEW programming here and drop some while loops around all these guys and then tell them all to run once. And then let's just see if that knowledge base entry knows what it's talking about. Okay, we got 4 while loops that are all going to run once. This code did take 0.29 now. Holy crap, it's running in parallel. So now you know why the knowledge base entry is still there. I think we can all agree that that's pretty ludicrous. So what in the world is going on here? All right, let's talk about clumps. Who in here does not know the term clump as it relates to LabVIEW? Several people. All right. I have some homework for all of y'all. Go to Google and search LabVIEW compiler under the hood. It's an article on ni.com that I'm dead serious you should read once a year. Make a calendar entry because you're going to read this like I just did 2 weeks ago. Then some time's going to pass. You're going to forget a lot of those details and you're going to go read it again because this article is one of the best things on ni.com. Let's face it, there's not much good to say about ni.com, but one of the good things we could say is that article right there. Sorry for the really green link. But yeah, that article is going to describe a lot of the stuff about the way the LabVIEW compiler works. And one of the things it's going to talk about is clumps. So there are some steps between your LabVIEW block diagram and the machine code that actually executes when you click the run arrow. One of those steps is that your diagram is converted into some things called intermediate representations. And during those steps, parts of your block diagram are grouped together in things called clumps. When there are clumps that don't have data dependencies, they can run in parallel. Now, some nodes in LabVIEW, it's my impression that most nodes in LabVIEW have a flag on them that says it's okay for this node to start its own clump. So, if this node or this group of nodes has the ability to run in parallel, that's okay. You can go ahead and run this in parallel with other things. While loops have that flag set on them. And by association, anything inside of a while loop has that flag. So a while loop and its contents can be turned into a clump. A Python node does not have that setting. However, y'all just saw my demo VI. They worked perfectly fine in parallel. We even have the dumb knowledge base entry that tells you to wrap while loops around them. So the Python node should probably have that flag too. And there's a bug file to LabVIEW R&D to do that. But as far as I'm concerned, having to wrap code with dummy loops is like smacking the side of LabVIEW to see if it'll work better. So that's ridiculous. We shouldn't have to do that. So keep an eye out for other things on block diagrams where things seem like they should run in parallel, but they don't. All right, last act. The answer to the ultimate question of life, the universe, and everything, sorry guys, it's not 42. It's 24. All right? So we got another case study here where someone was using actor framework, and they were noticing that whenever they spun up 24 or more actors, all the messaging between their actors started slowing down. Like 23, or 1 through 23, perfectly good, normal speed of messages being sent between them. As soon as that 24th actor got spun up, messaging between all of them slowed down, okay? Now, the actors were calling DACMX read, and the problem occurred with real DAC devices and in-house at NI simulated DAC devices. If you remove the DAC calls and replace them with some sort of simulated data, the problem stopped. So I was like, all right, I can take this football and I can punt it over to the DAC team because it's not a LabVIEW issue. But hold on, remember my number one goal. I want to help you guys get unstuck. So I didn't punt quite then. I mean, the DAC team was made aware of the issue, but I was like, let's see what else we can figure out here. Because I was curious, why is it 24? That's a weird number. It's not a power of 2, it's even. But what, why would DAC have that limitation, right? The actors, we know actor framework, actor VI is reentrant. DAC MX read VI, have you ever looked at it? It's inline, so its code just gets pulled into its caller. We know there's a DAC issue because when we pulled the DAC VIs out, the problem went away. But I had to find out, is there some limitation that LabVIEW itself imposes on a number of parallel threads that can execute? As a matter of fact, there is. So this file is your LabVIEW log file. If you go into your OS temp folder, you'll see a file with LabVIEW bitness version username log, or cur if you're currently running LabVIEW. You'll find that file in your temp folder right now. And if you go dig into that file, you see some really interesting stuff. But one interesting thing you see is all of the times where LabVIEW is starting a new thread in an execution system. And the really interesting thing is that we're told not only which thread number it is, but what the capacity is. And it turns out every execution system in LabVIEW has a capacity of 24 threads. Why? I don't understand. So it turns out, let me get back to my slide view here. All right, there it is. You guys know in the VI properties, you've got the execution system like standard, instrument IO, all that stuff. Well, each one of those, LabVIEW will spin up a maximum number of threads. And there's like some math in LabVIEW that like calculates this, but for all intents and purposes, that value almost always ends up being 24. The ludicrous thing about all of this is that there is an INI token you can use to bump that value to whatever you want. So that INI token is exec thread grow capacity. So by default, that value is 24. So that's the max number of threads you can have in an execution system. With that INI token, change it to whatever you want. In the case of the LabVIEW user I was helping, he used that INI token, he bumped the value up to 48. I don't know, we just doubled the number. And it totally fixed the problem. His actors all started working great, no delays between the messages, all because of that ridiculous INI token we had to add to LabVIEW. But I wasn't really happy with that fix. I mean, I'm glad we got the LabVIEW programmer unstuck, but I wasn't happy with that because what if he eventually spins up a bunch more DAC actors and now he hits a limit and now we got to bump that thread count again? Why is this happening in the first place? Maybe we need to know like why LabVIEW has that restriction and why this user was encountering a situation where just more threads solves the problem. This might be the most important slide in my presentation because this was something I did not know and it's fascinating. Reentrant VIs. You've got VIs that can be reentrant, VIs that can be non-reentrant. When you have a reentrant VI and multiple instances of the VI are accessing shared resources, the operating system is responsible for regulating, basically putting those threads to sleep, waking them back up when there's a shared resource. When a VI is non-reentrant, the OS is not involved. The LabVIEW execution system is what decides when to sort of order things to happen so that shared resources can be accessed in a particular order. Come back, slides. When you're managing threads at the OS level, it's highly resource intensive. The LabVIEW execution system is really, really good at managing resources for threads, and it's much less resource intensive. And it turns out that in rare cases, if you put a non-reentrant wrapper over reentrant code that has a shared resource, your code is going to run faster and more efficiently than if you just leave everything reentrant. Isn't that crazy? It's crazy. So the results were the customer system was solved by bumping the INI token, and we tested that internally at NI. It also fixed the issue. Internally to NI, we also tried my idea of wrapping DACMX read with a non-reentrant wrapper VI. That also fixed the problem internal to NI. It's unclear as to whether it fixed it on the customer system. But yeah, notice half the number of threads were required with that fix. Both because of the DAC issue, both approaches had the same performance. So in my opinion, playing with that INI token is a risky venture. I don't know if that's an official fix, because what if the number of threads gets bigger? I like the fix with the non-reentrant wrapper better. All right, I have 1 minute for an epilogue. Nobody loves LabVIEW more than me. I guarantee it, except maybe Jeff K. All right, I have had a 23-year career with this product. It's kept a roof over my head, my wife and my kids' heads. I've made a bunch of money as a LabVIEW programmer. I love LabVIEW, all right? I want all of us to be successful and not get stuck. Sometimes you get stuck in ludicrous ways. And when you do, I hope I can help, all right? Sometimes you never get stuck by avoiding features in the first place, like PPLs. Please avoid PPLs, all right? Thanks. I look forward to arguing with all of you over dinner tonight.
We could probably do about 2 questions right now if you want.
Oh, okay. Any quick questions?
On the non-reentrant wrapper, does that then bottleneck all of the asynchronous actors to wait until the reentrant function?
So yeah, but there was a bottleneck in the first place. It was the DACMX read was bottlenecking. So by putting the non-reentrant wrapper around that, we're now basically saying, hey, LabVIEW execution system, can you please throttle and serialize these things, instead of saying, hey, operating system, can you please serialize these reentrant VIs? That's why it's better. If there was not a shared resource, we wouldn't need to do that. One more question over here. That's going to be the last one. I want Enrique to have time to get ready.
I was just wondering if is that the same reaction on RT systems?
It could potentially be, yeah.
Okay.
I don't know for sure, but
Might
there's
be
no
running
reason
to
why
the-
that wouldn't happen there. Oh, was it an RT? That's right, it was a compact RIA. Okay, yeah, it was an RT system.
I'm borderline right there with the same setup, so I could be running into the same issue. Thanks.
All right, so you're probably going to take the easy way out and fix it with INI token, aren't you? All right, thanks everybody.
All right, thanks again, Darren.